All right, so welcome to the video on using a calculator for quadratics. So I'm gonna do my best here with this split screen because my first time splitting screen with this new app update and I'm not in love with it, but so if you hear frustration, I apologize ahead of time. Okay, so our goal today is to use a graphing calculator to analyze a quadratic function. And we can do this with polynomials also, but we're gonna start with quadratics. So here's our first example. It says Jackie Joyner Kersey won the women's pentathlon. Wow. During the 1992 Olympics in Barcelona, Spain. Her throw in the shot put can be modeled by, and then we have h of x equals, and then you can see you have a quadratic in standard form, and it is a downward facing parabola, where x is the shot put's horizontal distance traveled in feet, and h is the corresponding height in feet. So the first question is find the height of the shot put at its highest point. So I like to do a sketch so I can actually think about what's going on right here. So we have a downward facing parabola, and all that we care about is the first quadrant. So I'm going to draw a first quadrant here. And if you look, we know the y-intercept is 0, 5.5. So I'm not going to put like my downward facing parabola like that. I'll put it like this. Whoa, okay, sure, why not? Okay. And I only put the first quadrant because we don't care about like anything over here, and we don't care about anything down here because those are negative, and that's not even a possibility. So x was the horizontal distance, and y is the height in feet. Okay, so this is horizontal distance in feet, or sorry, height in feet and horizontal distance in feet. All right, so the first question is, what is the height of the shot put at its highest point? So if you look, that is right here, and it'd be the y value, right? So I want the y value of the vertex. So we're gonna use our graphing calculator to do this. So we are going to go to y equals. If anything's in there, you wanna hit clear, okay? And then we're gonna type the equation. We got negative 0.021 x squared, and just watch your screen as you're doing it. I'm trying to do that, plus x plus 5.5. All right, now if I hit graph, it's gonna graph it on that negative 10 to 10, negative 10 to 10 graph paper. So you can see that I'm missing the max, like the highest point. I'm missing the right side of the graph. So remember, I only need the first quadrant. So now I'm going to fix this so I can see the first quadrant. So I definitely need to make my x's go farther out. And it looks like I didn't hit the middle of, I didn't hit, like, it feels like I got like this much of it. So I'm going to go more than double. So I'm going to go, it's at 10 right now. I'm going to go like 50 is my guess. And then for my y values, I'm gonna go to like 20 and see if I got there. All right, so I'm gonna change the window here. So I'm gonna hit the window button. My x minimum, so it's asking me how far I need to go to the left, and I'm gonna say 0 because I don't need negative x values. My x max, I said I would do 50. Don't ever bother changing the scale. My y min 0, and my y max, once again, educated guess, I'm gonna go with 30. And if it doesn't show up, I think I said, yeah, I'm gonna do 30. All right, so if it doesn't show up, then I'll fix it again. So graph, come on, come on. Oh, I just missed the end there. So notice it's a lot of like trying, right? So I'll change this to 60 and hope that I get there. Voila. Okay, so there's my graph right there. I now need this point right here. Remember, that's called the vertex, and it's also the maximum of the graph. So to find that, I'm gonna hit second, trace. Option number 4 is maximum. And then I have this flashing cursor here. I need to be to the left of the maximum first because it asked me for a left bound. So I want this flashing cursor like somewhere over here. Come on, and I gotta hit. You guys can hold down on your calculator. I have to keep tapping. Hit enter. Then it asks for a right bound, so we're gonna get somewhere over here. So keep hitting to the right. Snooze-a-palooza. Keep going to the right. There you go, girl. Okay, hit enter, and now it says guess, and that's not your answer. That's just like, should we guess in between these two arrows here? And the answer is yes, so hit enter. And then I'm gonna write down right here what the ordered pair point is, so in case it asks me for the x value at any point, I don't have to work for that. So that's 23 point, and we're gonna do 3 decimal places always, so 810, comma, 17.405. So that's the ordered pair point. If you look back at question A, it asks us find the height of the shot put at its highest points. That's the Y value. So that is 17.405 feet. And then part B asks us determine how far the shot put traveled when it first hit the ground. So if you look right here, this is where it hit the ground, right? So we want to know what that point is right there. So that is an x-intercept or a 0. So now I'm going to find that 0. So I'm going to hit second, trace. Option number 2 is 0. And we are going, don't know what that just did. That was interesting. We're going to hit trace and we're going to get a left bound again. So remember that this parabola looks like this, okay? And we want a left bound. This, anything over here is to the left, anything over here is to the right. So we want that cursor to be like there, and then when it disappears off the screen, it's to the right. So I'm already to the left of my 0, but I have to go below the x-axis. So I'm gonna keep toggling because it's my favorite thing to do. Just toggle, toggle, toggle. All right, I'm gonna say this is my left bound. And then I'm gonna go until I'm below the x-axis. And I can just watch my y values, and when they hit negative, like now, I'm below my y-axis. In between these 2 points, yes, what's the 0? The 0 is 52.598, comma, and then it says -1e, -12. Please realize that that's 0. It's just a pixelation error. It's saying it's -1 times 10 to the -12th power. So take this and move this over 12 spaces. It's 0. It's just a pixelation error. Okay, so when did it hit the ground? Or sorry, how far the shot put traveled before it hit the ground? And that is 52.598 feet. Okay. Let's go ahead and try another one here. Very similar workings to this. We're gonna have to find a window, and then there's just a bunch of examples after this. All right, so, and then I'm just gonna do the first 2. Maybe I'll do them all, who knows? But the first 2 on the calculator for sure. In firefighting, the path of the water from a hose can be modeled by this equation. And then it says where x is the water's horizontal distance in feet and y is the corresponding height in feet. So I have the exact same picture here. I was going to copy and paste, but I did so much writing on that one. So like this. Once again, I know this y-intercept right here is 0, 3, so I'm not putting it at 0, 0. This is horizontal distance, and this is height, both in feet. Okay. I put f of t instead of feet. You can tell my math teacher, huh? Okay, what is the maximum distance the water will travel? Okay, what's the maximum distance the water will travel? So once again, that's our 0 that we just did right here. So that's this. We're gonna do the same exact process, okay? So we're gonna go to y equals, clear this out. Otherwise, I'm gonna find the 0 of that again, which I don't want. I got -0.003 x squared plus 0.62x plus 3. Okay, if I hit graph right now, it's gonna put it on the exact same graph paper that I just used. Maybe it'll fit. I'm gonna hit graph and see what happens. Close, but no cigar. So it's got about half of it. It went to like here-ish, let's say. So I definitely have to make my x values much bigger. And then my y values, once again, it looks close, but I'll make my y values bigger too. So I'm gonna go to my window. Right now my x max is 60. It looks like it's not gonna even if I double it, it's not good enough. So I'll go to like 300 as a wild guess. And then not changing the scale, my y min, I didn't really check it out, but I'm gonna go 100 to try to be safe and hit graph. Let's see, look at that. Okay, so there she is. All right, so what's the maximum distance the water will travel? I need to find that 0 again, so I'm gonna hit second, trace. Option number 2 is 0. I need a left bound. I'm already to the left of the 0. I'm just gonna get closer to it for reasons I stated previously, okay? So left bound, and then I need a right bound, so I'm just waiting for it to go to a negative y value. Enter, and that is 211.397. 211.397 feet. Okay. All right, next, when will the water reach its highest point? So let me get rid of this line that I just drew there randomly. So this is the highest point. The when will the water reach the point? That sounds like a time to me, so it's kind of icky, okay? So it should be at what height? I don't like the word when there, icky. But that is the X value I'm looking for, right? Like when, not what is the highest point. So we're gonna do a maximum again. Second, trace. Option number 4 is maximum. I need a left bound, so I'm gonna toggle till I'm to the left of the max. I just did the 0, so I gotta get that cursor to come back to be to the left of the vertex, the left of that highest point right there, which is called the maximum. Okay, I am to the left of it, it looks like, just to be safe right there. Enter. Now I need to get to the right of it, so I'm gonna toggle till I'm to the right of it. That looks good. Enter, and then it says yes, yes please. All right, so that ordered pair, I'm gonna write down both just in case the next question's asking me for what is the highest amount. So this is 103.333, comma 35.033. Okay, so when, I don't like that question, but at what distance, that's at 103.333 feet, it'll reach its highest point. And then the last question, how high is the water when it traveled 15 feet horizontally? So I want to know 15 comma what is the y value. So I could plug 15 in for x here and here and get it, but there's a way to do it on your graphing calculator also. If you just type 15, right, it'll plug in 15 for x, and if you push enter, it'll tell you the y value. So that is 11.625 feet. Okay. All right. Next one here. So we have an amusement park sells photos of people who ride the log flume. I don't even know what that is. Okay. The park puts an aluminum frame, there we go, of uniform width around each photo. So all that we're talking about is a photograph, right? The outside of the frame measures 6 by 8 inches. So I'm gonna label that here so I don't have to read that again. So I'm gonna put the longer is the 8 inches and then the shorter is the 6 inches, okay? Write a function that represents the relationship between the width of the frame, x, and the area, a of x, of the picture region. Explain the meaning in the terms of your equation. So basically, we don't know, I'm gonna use a different color here. We don't know how long this is, okay? That is going to be x, right? That's the width of the frame. And we don't know how long this is. That's x right here. And that goes like everywhere, like that's x, that's x. This is x, right? It's the length of the frame in all directions, right? So we wanna write an area formula for just the photo itself, right? So we can go ahead and do that. We're gonna say a of x is equal to, and then, yeah, just the picture region that we want. We don't want the 8 by 6 and we don't want the actual frame. We want just this part right here, okay? So I need a length and a width for that. So the length is this much right here. Now, if you look right here, the whole thing is 8, but I got to get rid of this and this. So that's 8 minus 2x. And then the same idea for the width. Like this is 6, but I just want this part right here, so I got to get rid of this and this. So that is 6 minus, oops, I put comma instead of minus 2x. So my equation is going to be length times width, 8 minus 2x times 6 minus 2x equals a of x. All right, the next question says, rewrite your function in an equivalent form. So let's put it in standard form because it's not in standard form right now. So we are going to FOIL. A of x is equal to 48. And then that's negative 16x and negative 12x, which is negative 28x. And then negative 2x times negative 2x is plus 4x squared. This is technically not in standard form yet because it is not written highest exponent to lowest exponent. So 4x squared minus 28x plus 48. So there's my standard form. Now it says create a graph to represent the relationship between the width of the frame and the area. So now we're going to draw what that looks like, okay? So we have frame width, and area. Okay, so x values to the area. So we can put this in our calculator to see what it looks like, but I do know that it looks like a parabola, right? And if we want to see our x and our y intercept to see where everything hits, we can, but let's go ahead and put it in our calculator and just to get an idea of what it looks like. So we have 4x squared minus 28x plus 48. Okay, did I try typing over that? I'm not happy about that, but I'll just do it again. 4x squared minus 28x plus 48. Okay, if I hit graph, I'm pretty sure I'm not going to be able to see it. So, oh, it looks icky, right? So my x values are going way too far, okay? So I am going to make my x values, my window, a lot less here. So I'm going to do my x max. I'll do like 5 and see what happens with that if it gets better. Wow, that's beautiful. Okay, so if you look, it zeroes out and then it pops back up, but we only care about that part right there. Okay, all right, so that's what it looks like, and we can find those x and y axis values if need be, but that's just an idea of what it looks like. Okay, all right, so if the area of the picture region is 38 square inches, what's the width of the frame? So I want to know if a of x is 38, what is x? Question mark. So if they were saying that the frame width is 38, I can just once again hit 38 and it'll tell me, but it doesn't do that for y values. So what we do for that is this is the same thing as y. We are going to graph the line y equals 38. So I'm going to go back to y equals. I'm going to graph the line y equals 38 and hit graph. And what it's going to do, it's going to create a horizontal line right here. So where they intersect, which is right here, is that x value, that is the width of the frame that it should be for an area of 38. So to find the intersection, we're going to hit second trace. Option number 5 is intersection. And if you see the intersection on the screen, you can just hit enter, 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 which I see the intersection. I'm going to hit enter, enter, enter. See, and it found it for me. Isn't it wonderful? So that x value at 38 of a y value is 0.378. So 0.378, and that was inches. All right, last question. If the width of the frame is 0.8 inches, so if x is 0.8, what is the area? So when they ask me for the y value, and I've given me an x value, all I got to do is type it in. So I'm going to do 0.8, enter, and I know that there's a mistake being made right now, but I'll show you what it is. It's going to say 38 because it's on the line. I need it to be on the parabola. So you can either delete the line, so go back into y equals and delete it, or you can just toggle down so it goes back to the line, and so that it'll go to 0.8, comma 28.16. Oops. So 28.16 inches squared, because it's area. Okay, there's one more problem left, but I'm going to have you pause the video and try it yourself. And then you can come back and check your answers. All right, so on this one here, create a graph that models it. So it looks like this. It's a downward facing parabola. This is the point. This goes up to 75 right here. And this is your height, and then this is time in seconds. And if you find the x-axis, or sorry, the x-intercept right there, that goes up to 5, okay? All right, so B's answer is after approximately how many seconds is the roller coaster off a height of 20 feet? So graph the line y equals 20. You get x is equal to 4.282 seconds. And then C, use the graph to estimate when the roller coaster goes underwater. So when it goes underwater would be right here, and that is 5 seconds. And you use that, find that using the zeros. Okay, that's it for the first lesson on using your graphing calculator to graph quadratics.